Hello everyone, welcome to my channel. In this series of videos, we are solving algorithm challenges that we find on the internet, and this is Project Euler.net. In the previous video, we solved the Project Euler's problem number 5, which asks us to find the smallest multiple of all numbers from 1 to 20. However, we implement a mathematical solution to find these multiples from 1 to 20. Although it's a completely valid solution, we can also implement a code to solve it. In our solution, we found the least common multiples by manually finding from all numbers from 1 to 20, but we can also make a solution with an algorithm. So let's do it. We can give it a try. For that, we need the function that we implemented for problem number 3, right? Which is the function to find the next prime and whether it is a prime. Since these functions are going to be recycled, I'm just going to refactor a little bit my project here. I'm going to create a package called utils. In this package, I'm going to put a Python file called prime functions, in which I'm going to have functions that are related to prime numbers. I'm going to copy these two here to my prime functions, right? Import math, just to refactor this one here from utils.primefunctions import next prime, just to not leave it broken here, right? So this would be my problem number 3. Later I'll test it to make it right because we're trying to solve problem number 5. I'm going to leave the solution here, but now the coding solution, right? So from utils.primefunctions import my function, which is next prime, because I'm going to need it. So first, we're going to implement a function to find the prime factors of a number, a given number integer, and this should return the prime factors. I'm going to represent these prime factors as a dictionary, just because I want to do this way. So this function finds the prime factors of a given number. So this is the number, and it should return dictionary with the prime factor of the number. Okay, we're going to start with a prime that is 2, and I also need to instantiate here a variable which is going to be a factor, right? This is going to be a dictionary that will represent my prime factors, right? So the idea here is that I will start dividing this number n until I find just 1, and I'll divide it by the prime numbers. If I find an even division, this is a factor. Otherwise, it's not a factor, right? So let's do like this. While my number n is bigger than 1, if the rest of the division of n by the prime is 0, it means that if it's evenly divisible, I'm going to update my n with the division by the prime number, and I'm going to put these factors to this new as a new prime factor. Therefore, I'm going to write it in this way, right? So here what I'm doing is I'm updating the dictionary in which the key is the prime, and I'm adding how many times this prime factor, this prime is a factor of the divides the number n. So for example, if it's the number 8, the key should be 2 and the value should be 3 because 2 power 3 equals 8. If it's not a factor, I'm just getting the next prime, right? So prime is equal to the next prime, the function that we implemented before, and it's saved here in the utils. Okay, once we have these factors, we return the factors, right? Let's test this function. I'm going to call it print factors of, let's give a number 20, the number in the example. So we're going to call the function prime factors and pass the number 20. Okay. So yes, this is right. 2 power 2 is equal to 4 multiplied by 5 power 1. We have 20 as the factors of 20. This works. Let's give it a different number. For example, 2. I'm expecting it to be just 2. Yes, that's right. If I do 1, how it's going to happen? If I pass 1, I think it's going to give you an empty. Yeah, it's not that right. So I can just, if n equal 1, return 1, 1. This should be. Just a pause here to say something. I know that 1 is not a prime and doesn't make sense to represent this way, but this is just to return something on the function so it doesn't break this case. But we're not gonna reach this case, right? So, okay, we have the function to implement the prime factors. We can do the same thing now. We can make another function for to find the least common multiple, right? For a collection of numbers. Let's just implement this function. I'm going to call it LCM, least common multiple. And here I'm expecting a list of numbers to be my input. And the result should be an integer. So find the least common multiple of a list of numbers. Given list of numbers should return the LCM result, right? Here, I'm gonna generate all of the prime factors from the list of numbers and then implement find the highest power in between them. So let's go for it. For number in numbers, I'm gonna generate the factors. Let's call it factors. I'm gonna call the function prime factors and I pass the number. Okay, here I have a dictionary with the prime factors. Now I'm gonna put these factors within the bigger dictionary in case of repetitions, just to find out the highest powers. Again, I'm instantiating here a new dictionary just to merge the results, right? So for each prime in the factors that I find, if the prime is not in the dictionary with all the factors, or the factors of the prime is bigger than the one that we have stored before, we just replace it, right? So if the factors prime is bigger than all factors prime, we just replace all factors prime with the factors prime. I'm going to change this variable name. It's going to be highest factors. I prefer this name. Is more intuitive. Now we just need to multiply them. So let's just create a variable here called product for prime in highest factors, product multiply, then the prime power, the highest factors prime, and then return the product. Let's give it an example to see if we can do it. So let's check the LCM of all of the numbers that we want to do here. So 1, 2, 3. I'm going to just do this in a different way. So for I in range 1 to 21, I. So let's run it to know if we find the result. Yeah, so we have the same result pretty much here. Yeah, that is correct. Yeah, so this function here to find the prime factors of a number and also to find the least common multiple are not the most optimal function for doing this thing. There are better ways to do it, but for the scope of this problem, we're gonna leave it like this. Okay, so thank you so much for watching. I hope you enjoyed this problem. This is a very exciting problem. And if you like it, please share, subscribe. Yeah, and I see you in the next problem.